Hello everyone. In this session, we are going to see another membrane technique used for external treatment of water, which comes under desalination of brackish water. So in previous session, we had seen electrodialysis, and in this session, we are going to discuss about reverse osmosis. So what is reverse osmosis? The flow of solvent from higher concentration to lower concentration solution through semi-permeable membrane by applying slightly higher external pressure than osmotic pressure on the solution of higher concentration is called as reverse osmosis. So while looking at the definition of reverse osmosis, we need to understand that there are two solutions of different concentration. One is of higher concentration, another is of lower concentration, and they are separated through a semi-permeable membrane. So semi-permeable membrane is made up of biological material, and in softening of water, in treatment of water, one example of such semi-permeable membrane is polyvinyl alcohol. So there are two solutions of water of different concentration which are separated by a semi-permeable membrane, and in this method water is forced to flow from a solution of higher concentration to lower concentration by applying some external pressure which should be greater than osmotic pressure, and this pressure is applied on the solution of higher concentration. So what exactly is osmotic pressure? We will understand further with the help of a diagram. So this technique, reverse osmosis, is also known as the finest hyperfiltration technique, which can remove particles as well as dissolved ions from the solution. Therefore, it is called as a hyperfiltration technique because it is very effective in softening of water. Also, reverse osmosis is most commonly used in our daily life for filtration of water. So the filtration filters which we use at our home for converting hard water to soft water, for purifying our drinking water, those are actually RO filters. So RO stands for reverse osmosis. So the filters, RO filters which we use for purification of drinking water, those are based on the principle of reverse osmosis. Now let's look at the first diagram here. On the left hand side, you will see what is the arrangement exactly to understand this process. So we have two solutions of water of different concentration. Means we have water samples of different concentration. The water which is having high concentration of dissolved salts, we can call it as a saline water, and another is pure water in which the concentration of dissolved salts is less or not present at all. So that is a pure water. So these two water are separated by a semi-permeable membrane in the middle. As I said, semi-permeable membrane is made up of biological material, and it is a membrane which allows only solvent molecules to pass through it. So this is a solution. Saline water is a solution in which the impurities, the dissolved salts, are solute and water is a solvent. So semi-permeable membrane allows only the solvent molecules to pass through, and it doesn't allow the dissolved impurities of salts to pass through it. So it allows only solvent to pass through, and it does not allow the solute particles to pass through it. So there is saline water, there is pure water, and they are separated by a semi-permeable membrane. So in reverse osmosis, what we do, we apply a pressure on the solution of higher concentration, and this pressure is also called as external pressure, which should be greater than the osmotic pressure. So as we apply the pressure on the solution of higher concentration, the solvent molecules, water molecules, are going to pass through the solution of are going to pass through the semi-permeable membrane from higher concentration to lower concentration solution. So as a result of this process, we will get pure water at one side and all the impurities, salt impurities which were present in water will remain on the left side. So the overall result would be we will get pure water, that is softened water. Now, why do we need to apply the pressure over here? Because osmosis is actually a purification of water. We are using reverse osmosis. But osmosis is a natural phenomenon in which pure water, means there is a tendency of solvent molecules to pass from a solution of lower concentration, that is from pure water, to a solution of higher concentration, that is saline water, through a semi-permeable membrane. So osmosis is a natural phenomenon. Without applying any pressure, solvent has a tendency to pass from low concentration solution to higher concentration solution through a semi-permeable membrane, and during this process the pressure which develops here at the solution of higher concentration is called as osmotic pressure. That is why to reverse this flow, we need to apply a external pressure on the solution of higher concentration, which should be greater than the osmotic pressure. We are carrying out the reverse of osmosis in this method, so it is called as reverse osmosis. So in order to reverse the natural phenomenon, here we are applying pressure, operation pressure, which is higher than osmotic pressure on the solution of higher concentration, so that the solvent molecules will go towards the solution of lower concentration through through semi-permeable membrane. So this is the process of reverse osmosis, which is used for softening of water. Out of all the methods which we have seen in external treatment methods of water in the previous session, reverse osmosis is the most effective one, because in this we get the most pure form of water. Therefore, it is also called as a hyperfiltration technique. So we get very well softened water in this method. That is why RO filters are very commonly used in our daily life for purification of drinking water. So that's all for today's session. If you have any doubts, you can just put it in the comment box. Thank you.